6 parts 15 degrees each. So it will be divided. So my 0, 1, 2, 3, 4, 5, 6 will be 15 degrees of PQ. And my crank will keep on rotating what? 30 degrees. Let's see. Now we divide this particular point into 6 parts of 15 degrees each. As you can see in the figure, it is 15 degrees each. This is a 45 degree angle. So 15, 15, 15. Again, this is a 45 degree angle. So 15, 15 and 15. Okay. Now we need to draw the crank circle for these particular things. So we'll draw the circles. Draw the circles for these particular positions. As you can see at Q1, Q2, Q3. Then it goes at Q4. Then it goes at Q5. Then it makes at Q double dash. That is my extreme position. So I have the different position of my circle at different times. Now what is next? Now I need to find the position of 1 on Q1. Now what is basically happening, you can see this particular thing is rotating and this particular thing is moving. So what will happen from Q till Q1? If my link PQ is going from Q to Q1, my disk is rotating from 0 to 1. So I need to mark the position of say point 1 on this particular circle. How can I do that? See, I'll take the radius. I'll measure the radius from P till 1, because that is the straight distance, that is the maximum distance of point 1 from P. That is possible. So here on Q1, 1 is at a maximum distance from point P. So I'll take this particular distance and I will mark an arc. How will I mark an arc? Here I go. Here I have an arc, so I mark it 1. Now what if I want for 2? I'll measure the difference P. Here we go. For P, so for the second point I'll measure the distance P2 and I'll cut an arc on circle that is being made from Q2. Again for Q3, same distance P to 3. P3 is a distance. Mark an arc on the circle that is Q3. This is the this is the circle Q3 on which this is the point 3 that is marked. So we have 4, then we have 5, then we have 6. Now what happens? This is my extreme position that I have achieved. Now what? My crank cannot go beyond that. So when I want to mark my point 7, I'll take the same distance P to 7, but I need to mark it on what? I need to mark it on the circle position which is there after Q double dash, which is Q5. So my P7 distance arc will again come on the 5th point. As you can see, I'll take it again. Here we go. Right? Now 8 will come on again what? 4. Then 9 will come on 3. 10 will come on 2. 11 will come on 1. And again I have my 0. So I have the different points for different positions of the disk. I have the different points and the different position of the oscillating rod PQ. Now I just need to connect those points. So what will I do? I will draw the locus. I will join with a smooth curve. La 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 la. Again it is done. Start from 0, it goes to 1, it goes to 2, it goes to 3, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 0. This is a simple problem for which we have the required locus. Okay. So what have we learnt in today's session? We learnt what is a locus. What is a locus? It needs specific condition and a specific path. It connects the points and all the points, a set of points come on and prepare a locus. And some common loci that we encounter: circles, parallel lines and angle dividers, something like that. And then we have 4 mechanisms that we study. We studied with simple slider crank mechanism, locus on the connecting rod, then offside slider crank mechanism, locus on the connecting rod, 4-bar link mechanism, locus on the connecting rod as well as beyond the connecting rod, and lastly we discussed a pendulum which has a rotating disc at the end. So I thank you all for this session. I hope you all got knowledge that is required, and if you have any doubts, please feel free to contact on the email ID, or the best option is to go to your engineering graphic professor and ask your doubt, but clear your doubts. I have mentioned a very small tagline on my last slide: when you know better, you do better. So never quit knowing better. then you already know. Okay, thank you and have a lovely day, and keep studying and keep enjoying.